So today I'm going to be talking to you a little bit more about one of the projects that we recently conducted over a disused prawn farm in tropical northern Australia. So I will basically just tell you a little bit about myself and my company first. So there we go, that's better. So we have a company that's been operating for some years. We have a number of employees that collectively have over 80 years of experience, and we're proud of our award-winning history. We have a lot of happy customers and a lot of long days because we're very passionate about the work that we do. Our customers are distributed across a wide range of different industries, and they're notable. And we offer a range of services across geographic information, UAV services, and product sales. In terms of product sales, one of our major drivers is Emlid hardware, and we're very pleased to be associated with Emlid. And now I'll tell you a little bit about this project. So we were at work and we took a phone call just after lunch on a Friday afternoon. And the customer said to us, "We'd like to have you map a prawn farm and give us a digital terrain model of that disused farm so that we can redesign and remodel it and know what volumes of material are there that we can work with when we remodel the farm." It all looked pretty good. The challenges included this river on the bottom of the screen, which is in fact the mouth of a crocodile-infested river in tropical Australia. And we also have really aggressive snakes that live in long grass in the tropics, and they're called taipans, and they're the sorts of snakes that run after you, not run away from you. So we were quite nervous about the terrain, and it was about a 4-hour drive from our office. Anyway, the customer wanted to get the survey done as soon as possible, and we're already a pretty busy company. However, we were able to accommodate it the very following Monday and Tuesday, so just a couple of days after taking the call. So we spent a bit of time on Friday afternoon and Saturday morning preparing for the mission, and we threw a heap of gear into the 4-wheel drive and we headed north up onto Cape York. Anyway, when we got there Monday afternoon, we went, "Oh my goodness." And when I say, "Oh my goodness," I'm not talking about the spectacular views associated with this site. I'm talking about the really dense grass that occupied so much of the terrain that we were planning to map with photogrammetry. And we were like, how are we going to get a ground model out of this terrain? To give you a sense of how bad the grass was, the vegetation, this is the density and the height. It's sort of like over the bonnet of the 4-wheel drive, over the hood for the North Americans of the 4-wheel drive. And here's another photo to give you some context. Really dense. Like, how on earth are we going to get data out of that? So we had a little bit of a replanning. This is interesting. There was some good news. There were spots that were pure ground, so we could find those spots of pure ground. The trouble is, it's actually a really fine white clay. And I don't know if you've ever tried spraying a mark on really dry, fine white clay, but the spray can actually just blows the dirt away. It's like trying to put a survey mark on talcum powder. So we'd have to really gently use the spray can. And, basically it'd take about 10 minutes of gentle spraying to get each cross down. And each cross is about 1.2 meters long. So, like I said, we did a little bit of replanning, and we decided, given that we had some spare hardware, we would put a Reach RS on the bull bar on the front of the 4-wheel drive. And then if we drove that through the heavy grass and we measured the vertical offset from the Reach RS to the ground, we could create a ground-based point cloud that we could use to augment the aerial point cloud that we collected with our drone. So one of the other interesting things was that the permanent survey mark that was established for this project when it was first built 30 years ago, the only reference point nearby was completely overgrown with vegetation. And I was like, how on earth are we going to be able to cope in terms of setting up our base in such a heavily vegetated location? But as it happened, it worked quite well. So there's the Reach RS unit mounted on the bull bar of the car. So we had a existing 5/8 mount that we used to maintain a fix when we drive from one control point to another. And we put a quick release spigot adapter on it, and then we masking tape that up to stop it rotating around. What we were trying to do was to protect the antenna so that it wasn't so exposed. And you'll understand why when I show you a video in just a moment. So this is what we call bulldozer mode. So we've got the four-wheel drive in low range, and we're basically driving all over the prawn farm, including up on the walls of the prawn farm, to try and get as many points as we could. Now the thing was, we'd never done this before and we weren't too sure if it would actually work. Thankfully we didn't get any snakes when we were doing this, but we did get a lot of frogs disturbed out of the grass and coming up onto the windscreen of the car, which was problematic because we were using the windscreen wipers to try and get rid of all the woody weed seeds, but then we started squashing frogs, so we kind of had to stop that. Anyway, you get a sense of how we go about collecting our point cloud from the ground in bulldozer mode. So we couldn't get out of the car and walk it. Ordinarily you might go out and take some shots with your rover, but we didn't want to die, and we were concerned that that may be a realistic outcome if we'd gone walking around in this deep grass. So once we had collected the data from the Reach RS, we were able to process it using Emlid's RTKLib version in PPK, and basically we kept all the information that we needed to be able to pull that together with the point cloud derived from the drone, the surface model. So this is the log, if you like, from the rover. So you can see we drove around everywhere. Now, as I said, we'd never done this before and we weren't sure if it would work. As it turned out, it worked perfectly. You can see this is the location of the base, up in the woods on the side of a road. And then as we drove down here, it fairly quickly got a fix, and it maintained that fix quite well as we drove around the site. Yeah, in hindsight, knowing that it worked so well, I think we would spend more time collecting more of a log, but there was a lot of these areas that also contained, like, we just couldn't drive in there. It was just too harsh for the car. This is the RTKPLOT from RTKLib for the vehicle-based rover. So as you can see, there's some enormous changes in velocity on X, Y, and Z. However, there's also some quite static points in that. And those static points coincided with where we were conducting our aerial survey. So we were then able to take all of that information and bring it together with the data from the drone. So with the log data, it was a lot of data, and I can't remember the numbers, but it was a crazy amount of points. And it's a really good idea, by the way. I really encourage this methodology, and I think it's got a lot of potential. However, what we did is when we got the data, we tried to trim it down as much as possible to bring it back to make it nice and easy to work with. And we pretty much did everything we needed to do in RTKLib and in Excel, and then we brought it together in Pix4D. So this is an image that shows the point cloud of the drone survey. And you can see very little of the PPK log from the car, the bulldozer rover. And that's not surprising because so much of the site had vegetation on it that sits on top. So for those of you that do GIS, we ordered this with the point cloud layer on top and the PPK underneath it. However, if we strip out all of the non-ground points from this point cloud, you can see now that we had a lot more points in areas where there weren't many where there weren't many ground points that we could use to augment the development of our terrain model. Incidentally, there's also these points running along the roads where we were driving around, but because we got lots of ground points there, you just can't see those rover points here. However, if we tip this model on its side, you can see that we get very good vertical alignment between the bulldozer mode PPK point cloud from the ground and the ground points that were derived from the drone. So if we take this little area as an example, this grass is about 2 meters high and it's very dense. There's no ground points in there. So if we have a look at that, that's what the ground points look like in that area. And then you can see where we triangulate that data without any augmented data from the ground rover, the PPK on the four-wheel drive, and there's some huge triangulated artifacts in the terrain model here. However, if we now add in the PPK data from the four-wheel drive, we can then really improve the alignment and the creation, the resolution of that digital terrain model. So obviously this data set's still got significant problems in some areas where we weren't able to get the PPK, but in other areas where we have the PPK, we were able to really improve the quality of the data and the reality of it for our customer. And finally, you know, people say, well, why wouldn't you just use LiDAR for that? And I'm like, well, A, we didn't have a LiDAR drone on hand that we could deploy at a couple of days' notice. And B, it's a much more expensive solution for our customer. And they were after something, and it was just the right fit for them at that time. So a combination of relatively low-cost drone hardware and, you know, high-performance, low-cost RTK and PPK hardware from Emlid allowed us to deliver a really good result for this project. And just before I go, I'll share with you the outcome of some of these surveys. So we were driving home. It's a 4-hour drive from the site, and I noticed the needle on the car got right up into the red for the temperature, and I'm like, what could possibly be wrong? So we pulled over, and I popped the hood and looked, and you couldn't see the radiator. It was just a sandwich of organic material from all the grass that we'd been driving through. There's probably a couple of frogs in there too. So we had to spend a bit of time getting rid of all of that. And of course, this bulldozer mode does come at a price when you consider the paintwork on your car. So with that, I'd like to thank you very much for your attention and wish you the best for your expo experience. Thank you.